So picture this for a second. Imagine waking up tomorrow morning. You know your name, you easily recognize your family, but suddenly, every single memory you have ever made is just gone, completely erased. No past, no childhood anecdotes, no friends, no learned skills. Would you still be you? See, memory is this invisible foundation of our humanity. You can't see it, you can't touch it, but it literally dictates every decision you make and every person you've ever loved.
Part 1. The illusion of memory. Not a perfect recording.
Okay, let's dive into this. It's a super common misconception that our memory works like a video camera, just perfectly hitting record on reality. It absolutely doesn't. Memory is actually a complex biological reconstruction of electrical signals. And to really grasp why, we just need to look at the staggering scale of the human brain. 86 billion. That is the average number of individual neurons just firing away inside your head right now. But wait, it gets even crazier. Those 86 billion neurons, they share roughly 100 trillion synaptic connections. 100 trillion. Every single thought you have, every face you see, every whiff of coffee you smell, it all leaves tiny, permanent physical changes inside these connections. And those biological changes, scattered all across this vast, unimaginably complex network, well, that's what we actually call memories.
Part 2. Inside the memory machine. Where memories live.
So the brain doesn't just have one giant memory file cabinet somewhere in the back. Instead, it relies on a bunch of scattered structures, starting with the hippocampus. You can kind of think of this as the brain's temporary librarian. It's the gatekeeper that decides which experiences are actually worth holding on to. Without it, you physically cannot create new long-term memories. And we know this for sure because of a famous patient, Henry Mollison. Following a tragic surgery that damaged his hippocampus, he could remember his past just fine, but he couldn't form any new memories for more than a few minutes. His case completely transformed neuroscience because it definitively proved just how incredibly vital this specific region is. Then you've got the amygdala. It's tiny, shaped literally like an almond, but man, does it pack a punch. It stores emotional importance, which is why your highly emotional events feel so incredibly vivid. Meanwhile, you have the vast cerebral cortex. This is where those long-term memories actually move to be distributed. Visuals, language, complex skills, the whole shebang, they all get routed here. So the tiny, emotion-driven amygdala flags what matters, and the massive cerebral cortex stores all those complex details across totally different regions. So how do all these different regions actually team up to build a memory? Well, it boils down to 3 major steps. First up is encoding. And here's the fascinating secret about this stage. Attention is the ultimate gatekeeper. If you aren't paying attention, your brain simply never stores the information properly in the first place. Next comes storage, where those neurons we talked about actually strengthen their physical connections. And finally, retrieval, which is where the brain reconstructs the memory right when you need it. And this brilliantly illustrates exactly what happens during that storage phase, through a physical process called long-term potentiation, or LTP. When neurons activate repeatedly, they strengthen their pathways, essentially carving a lasting trail in your brain. Think of it like carving a physical dirt trail right through a dense forest. The more often you walk that exact same path, the easier and clearer it gets. Your repeated practice literally, physically reshapes the structure of your brain. What's wild is how these mental trails have totally different biological limits. For instance, short-term memory acts as a super brief holding space for just 15 to 30 seconds. It's like remembering a phone number just long enough to dial it. Then there's working memory, which is essentially your mental workspace for things like solving math or planning your day. And finally, long-term memory, which can last a lifetime. This includes explicit memories, like obscure historical facts or remembering your first bicycle, and implicit memories, like knowing how to swim. Those implicit ones are carved so deeply, they often survive even if other explicit memory systems are completely damaged. Part 3, the necessity of forgetting. Why we lose information. We tend to think of forgetting as this annoying biological flaw, but it is absolutely essential to our survival. Imagine if you retained every single leaf you ever saw on a tree, or every random conversation you overheard at a cafe. Your brain would catastrophically overwhelm itself. So we forget. Factors like natural decay, interference from other memories, lack of retrieval, stress, sleep deprivation, and brain injuries all play a part. But the crucial takeaway here is that sometimes the memory actually still exists in your brain, but that specific neural retrieval pathway, that forest trail we just talked about, is simply broken or temporarily blocked. All right, brace yourselves for a pretty unsettling twist here. Your memories can be wrong, like completely wrong. Psychologists have shown over and over that it is entirely possible to convince people they vividly experienced events that literally never happened. Why? Because memory is a reconstructive process. Our brains naturally mix hard facts with our own beliefs, our expectations, and sometimes just pure imagination.
There's this famous saying in neuroscience: your brain edits reality every time you remember it. You aren't hitting play on a saved video file, you are rebuilding the event from scratch every single time you recall it. This reconstructive flaw is exactly why eyewitness testimony, which we used to consider near perfection in the justice system, is now known to be surprisingly and sometimes dangerously unreliable.
Moving on to part 4, sleep, emotion, and memory. Active maintenance. It turns out sleep is vital memory maintenance. It is definitely not just about resting your eyes. During deep sleep, your hippocampus is incredibly busy. It is rapidly replaying the day's experiences, strengthening those neural pathways, and essentially filing today's events into tomorrow's knowledge. If you're deprived of sleep, this absolutely critical maintenance just doesn't happen, and your memory performance drops off a cliff. And right alongside sleep, emotion acts like a massive spotlight for your brain. When you feel intense fear, deep love, or total shock, the hormone adrenaline yells at your brain, hey, this matters. This cements those strong emotional events into your long-term memory for sure. However, on the flip side, extreme trauma can also totally overwhelm the system, distorting or even suppressing a memory entirely. That's exactly what we see in conditions like PTSD, where emotional memories become almost overwhelmingly powerful. Let's move to and see how this builds into part 5, the future of memory, ethics and technology. This brings us to a massively profound ethical question. Should painful memories disappear? Right now, scientists are actually exploring laboratory treatments and advanced brain-computer interfaces that might one day weaken, hack, or literally erase traumatic memories. Now, on one hand, this could be totally life-changing for people suffering from severe phobias or PTSD, but it raises a massive dilemma. If our memories define who we are, what happens when we start just deleting the painful ones? Do we lose a fundamental part of our humanity? While we let that sci-fi reality sink in, just consider what our adaptable memory machine is already doing every single day. Did you know London taxi drivers actually grow physically larger hippocampi just from memorizing thousands of complex city streets? Or that smell triggers some of our absolute strongest memories because those olfactory pathways wire directly into our emotional brain regions? Plus, like we said earlier, memories are temporarily editable every single time they are recalled. Your brain is continuously rewriting your memories throughout your entire life. So what does all of this mean? It brings us to one huge fundamental realization. Memories are living networks. They are definitely not static, dusty files locked away on some mental cabinet. They are dynamic, actual physical structures in your brain that are being physically reshaped by every single person you meet, every book you read, and every song you hear. Which leaves us with this final, incredibly powerful thought. You are literally changing your mind. The person you become tomorrow depends entirely on the memories you are curating, focusing on, and reshaping today.